Hi everyone, welcome to our 10th module of Verilog HDL crash course. In this module, we are going to cover functions in Verilog. So, before I start this video, just a small request. If you are visiting to this channel first time or if you have not subscribed this channel so far, I would request you to please do subscribe this channel and press the bell icon so that you would get notified as soon as I upload a new video. Now let's get started. So Verilog HDL functions. So Verilog HDL functions are declared within a module and they can be called from continuous assignments or always blocks or from any other functions. So for example, we have a function. Let's assume the name is my function. So these functions can be called by using the continuous assignments. That means by using the assign keyword. So we can use the assign keyword, then some variable x, and then we can call this function. So whatever the functions will return the value, that value will be stored in the variable x. So this is the one way of calling a function. And the assign statement here will get executed whenever there is a change in the input arguments of this function. Now the second way of calling the function is from an always block. So we have an always block. In always block also, in similar way we can call x is equal to my function. And if functions can be called from another function as well. So in a continuous assignments, they are evaluated when any of its declared inputs changes. So whenever the input arguments of these functions changes, this statement will basically get executed. That means this function will be called. In a procedural, they are evaluated whenever invoked. So when the functions are basically called from a procedural block, that means these functions will be called whenever this block is going to execute. That means whenever there is a change in the sensitivity list of this particular block, this always block is going to execute and then the functions will be called. And functions describes combinational logic. So basically by using the functions in Verilog HDL, we can implement combinational logic, and a combinational logic implemented using functions do not generate any kind of latches. That means in normal Verilog HDL, if we have if else kind of statements and if we miss the else statement, then it will generate the latches. But that is not the case in functions. If we do not have the else part of a conditional statement as well, then also the function is not going to generate any latches. Or as always, functions are good way to reuse procedural code since modules cannot be invoked from within a procedure. So this is a general concept of functions. Functions are basically used or they are useful in any of the language because they increase the reusability of a code. Because the similar code we can implement using the functions, and whenever that is needed, we can call that function in our project. So this is the basic advantage of function. Now let's see the function declarations, how we can declare a function. So a function declaration basically specifies the name of the function, the width of the function return value, and the function input arguments. The variables, the local variables used within the functions, and the function local parameters and integers. So this is what a functions will have. For example, here is the syntax where we have the function and the width of the return value. And then we have the function name here, and then we have all the input arguments, then internal variables, parameters, integers, and then the statements, and then the end function. So this is how a function declaration looks like. For example, here we have an example. So this function basically returns a 8-bit value and the name of the function is myfunc. So here we have one input, 8-bit input variable I, then we have the internal register variable and internal integer variable, and then we have the statements here. So basically the temp is nothing but OR operation of these values, and then the myfunc will get assigned this value. So here anyway we will be covering in later slides, but I just want to mention that a function, whenever we declare a function, a variable with the same name of that functions will be created, and that variable is nothing but the return value of that function. For example, here whenever we declare a function myfunc with the return value 8-bit return value, a variable with the same name myfunc and the width of 8 will be automatically created. So we have to assign the return value of the function to that variable. So that is what we are doing here. My function will get this value. So this function will return a value, 8-bit value, which is nothing but this value. So this is how a Verilog HDL function looks like. Now let's see the function return value. So as I said, when we declare a function, a variable is also implicitly declared with the same name as the function name and with the width specified for the function name. So if there is no width specified, then the default width will be 1 bit. At least one statement in the function must assign the function return value to this variable. That means whatever the function return value we are expecting, that value should be assigned to the variable which is nothing but has the same name as the function. Now let's see the function call. So if a function call is an operand in an expression, that means a function basically we can have as an operand of an expression. So whenever that expression is going to execute, that functions will be getting called, and whatever the return value of that function is, that will be used in the statement evaluation. A function call must specify in its terminal list of all the input parameters. So whatever the input parameters of the function are, that we should specify. So here if you see, we have a var variable x and another variable y which are 8-bit, and if you see here we had a myfunc function with 8-bit width. So these functions, how we can invoke this function? Here we are invoking this function using the assign, continuous assignment statement. So assign y equal to myfunc, and the input value is nothing but we are passing as this x. So this is how we can invoke a function or we can call a function. So this is one way of calling a function using continuous assignment. We can also call a functions from the procedural blocks or from one another function. Now let's see a few concepts on function return value. A function must contain at least one input argument, and a function cannot contain an input or output declaration. So if functions only have input argument, so basically a functions can only have the input arguments. It cannot have in-out or output declaration. And a function cannot contain any timing control statement like the delay statement, the event control statement, and the wait statement, which we covered in our previous module. A functions can invoke other functions but not themselves. So a function cannot be recursive, but a function can invoke another function. And functions cannot invoke tasks because tasks can have timing control statements. We will cover tasks as well in our next module, but the difference between function and tasks, one difference is functions cannot have timing control statements while tasks can have. And a function must contain a statement that assigns the return value to the implicit function's name register. So whatever the register variable which gets created when we declare a function, we should have at least one statement in the functions that will basically assign some value to that variable. Now let's see one example here. So if you see here, since a functions can only have input arguments, it do not have in-out or output declaration. So the function basically returns a value through the implicit declared variable. So whenever we assign the value to the implicitly declared variable when we declare a function, it will basically return the value through that variable and not have any kind of output declaration. So here a function has only one output, and that output is nothing but that function return value. And if we want to return more than one value, for example, here basically we are, if you see here, we are returning this value temp and I2 down to 0. So if we want to declare more values, that means if we have some variables here like x, y and g, suppose these are 8-bit variables, and these variables will be basically having some values inside these functions, and these values we have to return. So now how we can return these three variables value? So one way of doing this is using concatenation operator. We can basically concatenate all these values, which is nothing but 24-bit value. So we can declare a functions with 24-bit width, that means 23 down to 0, and then whatever the myfunc variable will be there, myfuncs will get all these variable values. So here we can use the concatenation operator, and when we get this value, then we will basically unbundle these values and we will use these values. So this is what discussed here. If more than one return value is required, the output should be concatenated into one vector before assigning into the function name. And the calling module program can then extract or unbundle the individual outputs from the concatenated form. So here we are going to discuss one very good example of function use. So here we have a simple processor decoding unit. So here we have a simple processor which has two arguments. One is instruction and one is output. So the instruction here is input, 32-bit input instruction, and then we have an output, 8-bit output value. Okay, and we have here some internal registers which we will be using. So we have one out P. This is nothing but our output variable, which is a type of register, and then we have some internal variables which is nothing but func and two operand 1 and operand 2 variable, 8-bit variable we have declared. Now this is nothing but a normal instruction decoding unit. So here we will get one instruction, and then what is that instructions, we have to decode that instruction, and based on that we have to generate the output. So whenever we get one instructions, we first want to decode that instruction. So that decoding is basically now completely depending on this instruction. So just pass the instruction and decode that. So this decoding unit will become basically common for all the instruction. So here we can have a function for this decoding unit. So we will pass the instruction to this function, we will decode these instructions, and we will get the required information out of that instruction. So here we have declared one function which is nothing but decode whatever that instruction is, and this function will basically return a 17-bit value. So those 17-bit return values will be, one is 1-bit value and two are 8-bit value. So basically it will return three values, three variable values. So we cannot have multiple output or multiple return values from a function. So we basically have to concatenate those all three values and then return a 17-bit value. So if you see here, we have the input, this is nothing but instruction. Then we have one internal variable add function, and we have two 8-bit variables which are opcode, operand 1 and operand 2, basically three variables. So here we are basically, so in the instruction we know that values or bits 22 to 31 are corresponding to the opcode. So we will extract that opcode informations, and then operand 1, the operand 1 will be nothing but initial 8-bit values. So now based on the opcode, what is the opcode, we will decode this instruction. So if opcode is this value, that means it is corresponding to the addition operation. So we have to add the two operands. So here we will set this add func variable, that means this is the addition operations, and here operand 1 is nothing but, we know the instruction 7 down to 0 is nothing but operand 1. So operand 2 here, if the opcode is this, that means the operand 2 will be our instruction register values 8 to 15. And if the opcode is this, that means it is a subtract two operands. It is the subtract instruction, that means our add func variable will become 0 and our operand 2 will be nothing but bits 8 down to 15. And if our opcode is this value, that means it is corresponding to increment operand, that means whatever so the add function again will become 1, because this is an increment operation, that means increment by 1. So add func will become 1, but here operand 2 will be nothing but a value of 1. So if our opcode is this, that means the first operand will be nothing but 0 to 7th bit, but the second operand will be a fixed value which is nothing 1, and it will not come out from the instruction 8 to 15 value. And default is nothing but a decrement operations, and in that case it is a subtraction, so our add func variable will become 0 and our operand, again second operand, will be 1 because we have to decrement it by 1. And this is nothing but AND case here. Now what we are returning here is the function which needs to be performed and the two operand values. So these three values basically we are going to return from this function. So now basically based on, so when we decoded the instructions, we decoded these three information. That is, one is what the functions the instruction is trying to perform, and then the operand 1 and operand 2 values. Now let's see how to call this function. So in another always procedural block here we are going to call this. So whenever there is a new instruction available, we will decode that instruction. So we will call this decode, so we will call this decode functions, and we will extract these three information, that is function, operand 1 and operand 2. And now if our function is 1, that means it is addition operations either by 1 or by operand 2. So here the output will be nothing but operand 1 plus operand 2. If else, that means it is a subtraction and our output will be nothing but operand 1 minus operand 2. So this is how we can make use of functions in a beautiful way in Verilog HDL. So I hope friends that the concepts related to functions in Verilog HDL is clear, and also how we can make use of the functions in Verilog HDL in a good way is also clear. If you have any doubts, please write down in the comment sections. If you like this video, please hit the like button and do not forget to subscribe this channel so that you would get notified as soon as I upload a new video. Thank you very much.